In this session, we'll be discussing timing diagrams. Timing diagram in their simplest form are just graphic representation. So in front of us here, timing diagrams. So you can see it is two-dimensional thing. So what is the purpose of the timing diagram? If you look at system board, let's say this is a system board in a computer. So what you will see different components, maybe different pieces scattered all over the board, and we understand there are some connection between them. There's always connection between them, and the connection here serve to propagate signal. Last time we talked about signal, and we said that computers use some sort of square signal going on and off, high and low, and that is the sort of communication that's happening between the different components. Time diagram give designer and technician a way to see how these components act or how they should act. So here, for example, we have different components. You can see them here. One is the clock, the address, and so on. We are not really concerned about what this specific timing diagram does. But what is important is to know that we have here the clock. The clock job is to maintain time. So this is T1, T2. So time goes in this direction. So this is the earliest time. This is the latest time here. And as you can see here, at certain time, something happened, some event happened, something happened, which is either a group of lines goes on and off, or single line, like you see this one, all right, going high or low. So they are very important tool to help us understand what's happening. But today we're going to do simple thing. We're going to use the Logisim. We're going to study the behavior of the logic gate AND. So you see here in front of us, this is AND. Okay, this is AND. It is the two input. So this is the first input, second input, and here is the output. So this is the input here, and always one output. And as you can see here, it doesn't really give us much information. However, the timing diagram, so this is represent the time, the pass of time. Okay, this is the latest, this is the oldest time. So it tells us what's really happening. So for example, here both A is 0 or low and B is 0. So what happened? When both are 0, the output is also 0. But when they change to high, okay, during this period, T1, the output get affected as well, and so on. So we're going to be using a Logisim to see how such a behavior happening. Here is Logisim. So what we will do, we're going to get the gate. This is the AND gate, and is the input. Second input, this is the output, and you can see the output is red. That means is not determined yet. It could be high or low, and here the blue means there is no signal. So I'm gonna have here input pin, and another one here, Okay, and then I'm gonna be using a device that helped me study the signal. You can find it here, and then input output extra, and it is called the digital oscilloscope. Okay, and you have it here. Okay, so by default it has 3 inputs, so you can see them here, 1, 2, 3, and also you see here this is for the clock that we talked about that help synchronize. So I'm gonna connect the output here to the last one, and here is the first. So I'll give it to the second, and here is to the first. Okay, so before this device to work, we need to connect it to the source of the pulses that get it to work, get it to run. And you can see it here indicated by this arrow. This is where I need to put the clock signal. And the clock signal can be found under wiring. And here it is. Here's the clock. And then it'll have some connection to it. Okay, now my device is ready, so I'm gonna run simulation. Okay, and by clicking here you can see, so every time I do this I have a pulse coming on. This is one pulse, so you can see it here. This is another pulse. Every time I click I get a pulse. So this is the first one, this is the second, and so on. And a crucial thing that we should pay attention to is this the raising edge. So that means when the signal goes from low to high, and this is indicated here using this dash vertical line. Let's see it one more time. Okay, so now you will see it. So this is one pulse. Okay, it started high, and then you're gonna start again. So this is one pulse. When I click one more time, it's another one. Okay, so let's see what happened when we change the input. So far we have here, you can see the two lines, the input, they both low. And how we know that? By looking at the first of all, you can see zeros here, but also Logisim shows the presence of zero in terms of dark green lines. So you see the dark green, so it means all of them are low at this moment. Okay, so you're gonna see what happened when we change the input. So I'm gonna change the first one into 1. So I click on that, and you can see it here. It is 1. So we're gonna give it a pulse, but again the output is still the same. And this makes sense because the AND gate only change to 1 when both are 1. So I'm gonna do that now. I'm gonna change the other one to 1. I can see it here immediately. It becomes 1. Okay, so you see here both of them are, so when both are 1, when the both input are 1, the output is 1. So if we change this one to 0, right, so it go back to 0 and so on. So that is how we understand the behavior of this gate. So let's say, for example, I want to try different gate. Okay, let's say I want to try OR gate. So I'm gonna take this guy out and get the OR. Right, and of course I'm expecting to see different behavior here. All right, so let's see what's happening. So it's remain 1 because OR gate output high when either or both are 1. So it's only 0 and both are 0. You can see it here. So it would be a good idea to experiment with it to see how it behaves with different gates. So you can go ahead and pick any of these gates and connect them to see how the timing diagram looks like. To have a more interesting behavior, I have here in front of me, as before, the oscilloscope here, the AND gate, and I added a counter. The counter is just generate numbers from 0 up to 3. This device, this configuration are stored in a file. You can find them under lab 3. So download it and open it and you will see it this way, but you can build it yourself. But here I don't want you to get distracted about what's happening here. So what is important is to see the behavior of this gate when used within a clock system. So I started this video by saying that in a digital system we're going to have different devices. So I want you to think of, we have this device, this are many of these. The gates are the input output considered to be immediate, but here, because we have at least this counter and this device, and we need to have some sort of coordination, some device that keep them in sync to synchronize their operation, and that is the job of the clock. You see it here. So we got everything is connected, so we're gonna go ahead and run the system. So we will go to simulate, and we can, instead of us clicking on and off, all right, so instead of just doing this, like something like that, and keep it changing, so we can keep it running. But maybe let's have a let's see what's happening here. So I want you to pay attention to this. So we see 0. All right, this is now 1, 2, 3, and it go back again to 0. So what does really mean? So here, when the both input are 0, 0, and the output is 0. So when I do it one more time, so what's happening here? So we have now have 1. So how we 1 in binary is 0, 0, 1. So remember, we read from the left to right. So 0, 1. So the output is 0. Now we're going to change it to 1. When you click this, you're gonna, what is next? With 2. 2 is what? 1, 0. Notice what's gonna happen. It's 2. This is 2. So 2 is 1. This is 1 and a 0, and the output is still 0. When I do it one more time, so both of them gonna go high. Both of these. So click it one more time. So you're gonna see they're about now 3, which is what? Both are 1. 1, 1. Only at this time, both of them are 1. Another interesting thing that we notice is that the output only get affected during the raising edge. Okay, although the signal will be on for a time. So let's just do this. So you can see it here. The the output get affected only when the clock is on the raising edge. So you can think of it as the output will be high when both input, okay, because this is an AND gate, and also the signal has to be on the raising edge and remain so. You can see it just remains so until the input change to 0, 0, and also there is another raising edge. You can think of a raising edge is like a gate. It lets the action take place. So this is the behavior stepwise, but I can do better than that. I can run it and see it moving like happening in real life. So I'm going to go to simulate, and I'm going to go to auto tick enabled, and I click it, and you can see it here as really working as if it is in a real life situation. And of course I made it slow here so we can observe the result, but you can go ahead and change the frequency. So the biggest the number, the fastest they go. Right, so here is just 1 hertz, which is really slow, but if I can go and make them faster, so we're going to go even faster. I can even make them go crazy fast like this. All right, but it's a good idea just to keep them reasonably fast so we can observe their behavior.